All right, I'm testing out some new software on my computer to see what it looks like. But you guys had requested that I do some practice questions from this practice quiz, the 4 through to 16, because I know that 2 to the 4th is equal to 16. I know the answer is 2. For those of you who don't know, I remember I told you this is a no-calc quiz, so you might want to look through, know your powers, especially up to around the 250 range, 16 squared. 4 to the 4th, both of those are 256, and that's about as big as I go. The next one, give the range of the rational power function, the fifth root of x, all of our rational power functions according to the definition in the book. I had a picture based on this shape right here, and so we were sticking with a domain greater than or equal to 0, just so that all the fractional exponent functions look the same. And so that would be your domain, but the range also y greater than or equal to 0. So because we were dealing with quadrant 1. Solve the formula for that. Well, you'd have to multiply both sides by 3 over 2. Okay, so that's pretty easy. 3v over 2 equals pi r to the 4th. Division by pi is the same as multiplication by 1 over pi. And then we would have to take the 4th root. And you can write that as a fractional exponent. So 3v over 2 pi to the 1/4 equals r. Or you could write it as a 4th root, 3v over 2 pi. Either one of those is acceptable. Some basic log questions, right? 4 to the x. 4 to the x is equal to 64. Well, I can rewrite that as 4 to the 3rd. Well, since the bases are the same, the exponents must also be the same. This one we practiced in class because a couple of you didn't see it, so I'll do it again. So I'm switching it to its exponential form. 125 to the x equals the square root of 0.04. We can rewrite 4 100ths and take the square root of the top. Square root of 4 is 2, square root of 100 is 10, and simply reduce that. Now I hope that it's a little bit more obvious that this is now based on the power of 5. So I'm going to rewrite this as 5 to the 3rd. Of course, you can't forget it's to the x power. And over here, this is going to be 5 to the negative 1st. That's how you get that base to flip over, right? 1/5 is 5 to the negative 1st. So we can multiply the power of a power, and now we can compare the exponents. 3x must equal negative 1, and the only way that can happen is if we're talking about negative 1/3. X equals negative 1/3. When you have a question like this and you got to solve for x, if you can't do it in its exponential form, you must change it to its log form. So the base is 5, the argument 42, and the exponent that it equals is x. Oh look, it is solved for x. Since I do not have a machine and I'm not allowed to use a machine, I'd have to leave my answer as an expression. I told you to do the root power flip thing idea, right? Always doing the root first, and the power second, and the flip last. So the root cube root of 64 would be 4, cube root of 27, 3. And then we square that, and that gives me 16 over 9. And lastly, we flip it over, 9 over 16. Root, power, flip. Of course, we talked in class about how the logarithm graphs look like this, and negative 3 be over here, so there's no solution to that. B, no solution. A couple of classes talked about this. The base is not written in there. If the base is not written in there, then it must be a 10. So 10 to the x power equals 10 to the 4th. And that means x would be 4. Okay, and log 1, well, keep in mind you're saying 10 to the x equals 1. That can only happen if x is 0. Log base anything of 1 is 0. Okay, so we had a couple more questions here. Where in the world is that sheet? Ah, there it is. So you had a graph, draw a basic sketch of a log function. Okay. Why is it super critical that I go through the 0.10? Well, because that's on every one of those graphs. I can't touch the asymptote. I have to have the basic shape to the function. And what's the domain? Well, it looks like greater than 0, but not equal to because of the asymptote. Range looks like every real number in the universe. Boy, this looks just like we did in class today. Let's see, equation of the asymptote. Well, that's the y-axis, therefore that would be called x equals 0. Don't give me the nickname when it talks about an equation of the asymptote. Choose one of the following: strictly increasing, strictly decreasing. As you go from left to right through the graph, looks like the y values continue to get bigger and bigger, so that'd be strictly increasing. Definitely, the y values are getting bigger. How many solutions does each of the following questions have? Oh, let's see here. This function only has one solution, right? Because that was the one, the odd powering function has one solution no matter where you are on the, whereas the even one, the even powering function, this one has no solutions, right? Because negative 16 never crosses it. This one is also the even, but it's got a positive, so it'll have two solutions. So it's 1, 0, and 2. So obviously, if there are 0 solutions, I can't write anything on line B. If there is a solution to this, you need to find it. This one would happen to be negative 3, right? Because if you take the fifth root of both sides, you know that that's negative 3. Taking the sixth root of both sides, right? Sixth root, we get plus and minus 2. Okay. So those are some answers for you.